My name is Nicholas Kimali, and I am the CEO and founder of Feather Electrics Limited. So, Feather Electrics Limited is a company. It's an R&D company, and we do product development, a lot of IoT products, and also we offer training to students or other people who are interested in the field of IoT and embedded systems. So basically, that's what we do. So we've been in the field for quite some time now. Feather Electrics was founded in 2014. And since then, we've been in this field of IoT and product development. So we've been able to develop quite some products out there in the market, which we have been able to put out there and partner with companies. So in today's discussion, as I will be taking you through IoT, I will also mention some of these products, how we made these products, and how we were able to push these products to the market. So to start off, I would like to thank you, all of you, for attending this session. I'm grateful to each and every one of you. So first of all, today we are talking about IoT. And what exactly is IoT? So IoT basically means Internet of Things. But you know, when you just say IoT, what comes to your mind? Like, if you hear the word IoT, like what really comes to your mind? Is it just the word Internet of Things, or do you have a mental picture of what this IoT is? So just to create a mental picture, just imagine that you are at work right now. It's getting late. Everyone is there, and there's no one at home. And the curtains are open, the windows are open. You have your security lights are off, and you want to switch them on. So basically what you would do is, if you have someone at home, you would, if you have someone, you would just call them and ask them, okay, so would you please switch off the lights for me, or would you, or switch on the lights for me? Would you open the curtains, and so on? But what if there's no one at home? What would you do? You would wish to be a Superman, so that you can either fly to your place, close the curtains, and then switch on the lights and go back to what you were doing. But now, with IoT, all that is possible. You make yourself a Superman, IoT. And how is that possible? So you just have to create a system, what you call now the Internet of Things, things that interconnect to each other. You can either use an application, app. You just press on the app, close curtains, and then the curtains will close at home. You press on the app, switch on the lights switch on. You can decide to use SMS. You can decide to send an SMS to your system at home, and then the system will decide, depending on the SMS, it will either open the door, open the curtains, or close the curtains, switch on the lights, and switch off the lights. So this is just one of the uses of IoT. Another example, that I really like using a lot. So it's very, very simple, but very powerful. So assuming that you are in an office, or rather a very large complex or a workshop, and then you find that the lights are on everywhere. But then the goal is to have, systems that monitor when there is no one, who is using those lights. They should just go off because, it's just a way of saving your energy. So what do? You will have to put sensors, and these sensors will, what you call maybe motion sensors, and the motion sensors will sense when there is no one in the room, and if there's no one, then they will send a signal to a controller, and the controller will then switch the lights off. So you actually give the machines, or rather the computers, the role of making the decisions for you. You already pre-program these computers to get input from sensors, and then they can make that decision. And then they can actually talk to each other. Sensors can send signals to the computer, computers can talk to other computers. And those are what we call things, because computers are embedded in things. Computers are now embedded in everything right now. Like phones. All phones are computers. Look at TVs, they are computers. Look at, washing machines. Look at everything is now what we call computerized. But then this computerization, making these computers more intelligent so that they can talk to each other, they can share information. So that's what we call the Internet of Things, because things are able to interconnect with each other, and they are able to talk to each other. So today, my focus will be more on, understanding how can we design and develop this Internet of Things and be able to actually monetize what we call the Internet of Things. So I would first like to, and by the way, I would like this session to be as interactive as possible. So if anyone has a question, please, you can ask it as I continue to give my presentation. You can just ask your question, and I will be honored to answer your question. So I will give you a story of how I started with IoT and how it has actually helped me this far. So when I was in campus, I started using, electronics, what we call microcontrollers. That was when I was in second year at the University of Nairobi. So we had this lab called the Fab Lab, which was, we used to call it the Fabulous Laboratory. And when I started interacting with electronics, my first IoT project, I was just wondering, like, when I'm seated here at the lab, is there a way I can just send an SMS to my room and close the curtains in my room or switch on the lights? So that was like, I got so like, this was a question that I asked myself, and I got so involved in it, and I decided, okay, fine, I'm going to do this. And how did I go about that? So the first thing is to come up with a model, exactly do I want it to? And I made a model which was rather, how do I want it to work? So I wanted to send an SMS. Once the SMS gets to the room, so this is a predefined SMS, close curtain, open curtain, or switch on light, switch off the light. Once the SMS is received by the module, then the system will understand and it will actually do exactly what I have asked it to. So my first thing was to get an Arduino. So I would just like to show you the module that I got. So this is an Arduino. So by then, when I was in campus, we didn't have Arduinos. By then, they were not around as they are right now. So we're using an 8086 microcontroller, which was, one of those very old microcontrollers. And then there was also GSM module. So instead of a GSM module, so this is a GSM module. So this is the module that you can put your SIM card inside this module, and then once you power it up, it acts like a phone. So this becomes your phone, and then your phone is connected to the controller. So this is the computer unit, and this is the phone. So what happens is there are some connections. They're actually labeled. So there will be sessions. So if you are interested, I will share my contacts. If you're interested, there will be training sessions detailed how to do this. But then these modules here, they are labeled. You can interconnect these two modules. So this is the one that you program. You actually have your code inside here. Then this is where you have your SIM card. So this one acts like the phone, and then it has an antenna. So you connect your antenna here, that pin there. So what happens is when you send an SMS, the SMS is received by this module. And once the SMS is received, this module transmits that SMS to this one here using what we call a serial communication channel. So once the SMS is received by this controller, which is basically a computer, we call it the microcontroller. Once it's received here, then the microcontroller will make a decision to switch on the lights. So in one of the pins, you can connect your relay. So this is a relay. So the relay is just a solenoid, meaning that because this microcontroller uses a maximum of 5 volts, and we know that at home we normally use 240 volts AC. So you cannot connect your bulb directly to this controller. So you need a module that will somehow interconnect the two circuits, meaning that you can switch on this module, and then this relay acts like a switch, your home switch. So basically with these three, so you have your controller here, your relay, and your GSM module. So with these three, you have already created a home automation system. So you can program your microcontroller, and the program will read something like, if you receive an SMS, for example, switch on lights, then just switch on the relay, and then the relay will in turn switch on the light. And if you receive an SMS, switch off the light, it will in turn switch off the relay, and the relay will switch off the lights. So basically, when you have like these three modules, you've already solved that problem. That is one of the ways that that you have like Internet of Things. So so that is exactly what I did when I was in campus. So another thing that you can actually do, which I want to show you, is using motion sensor, motion detector. You know, most of us, we've had challenges with security, and we want to be alerted if someone maybe passes somewhere, or we want if there's anything, any activity, we want to be alerted. And how do we do that? We install one of these modules. This is a sensor. So this one, we call it a motion sensor. So the motion detector or sensor has an output. You can see three pins there. So there's one which is power, the other one is ground, and the middle one is the output. So if it detects any motion, then this one, the output will be connected to the power pin, and it will be 5 volts. It will output 5 volts. But then if there's no motion, it will be at 0 volts. So it means that you can connect to one of the pins of the microcontroller. And then in your microcontroller, your program that you will write for the microcontroller will be, if that pin, assuming that you connect to pin 1, for example, the pins are numbered. So I hope that you can see. The pins are numbered from 0 to 13 and so on. So assuming that we connect to pin 1, we can program it in such a way that, if you receive a signal in pin 1, meaning that there is motion that has been detected. So if you receive a signal at pin 1, what do? Send an SMS. So we connect this module, the communication pins. So send an SMS, and sending an SMS, we have a code for that. And once you ask it to send an SMS, you have to communicate to this module. Which number are you sending the SMS, and what is the SMS? What are the contents of the SMS? And then this module will in turn send the SMS. So basically, once the motion is detected in your phone, you will instantly receive that SMS. So that becomes a solution. So now, most of us, we are thrilled by, these things because, they seem fun and all that. Let me tell you the truth. They are more fun than you think. They're actually more fun. And now, where is the problem? They are more fun. The problem is that these things are like alcohol. They become so addictive. And it's not a bad thing, it's a good thing. The only thing is most of the engineers or maybe developers, what we do is we end up making a lot of these IoT things. It's very interesting. Someone will come, they want to make maybe a dustbin that, once you just get close to the dustbin opens. You don't have to step on it. And voila, it works. But then after that, you think of something else. Oh, I can actually make a system that, a door system that will sense that it is me. And once it senses that it is me, it will open. You make that. But the question is, how do you move from this phase of prototyping? We call this the prototyping phase. How do you move from this prototyping phase of the IoT to make a real product that you will take to the market? So this one, what you can see here is a motherboard of a speed governor device. So you all know that in Kenya we have it's mandatory for all public service vehicles and commercial vehicles to be fitted with a speed governor. And these speed governors, they have to limit the speed of the vehicle at 80 kilometers per hour. So once when the government announced the speed governor regulation, we started actually developing a locally manufactured speed governor. So this is a locally manufactured speed governor, and it has the IoT capability. And when I talk about IoT capability, what do I mean? So this speed governor, it has so this module that you can see here, it resembles the module that I have just shown you, the GSM. You can see that. So this is GSM. So this module of the speed governor is a bit more powerful. It has a GPS global position system. So you can actually get your GPS coordinates with this module. And once you get your GPS, you can now get the position of the vehicle, send. So this one has GPS and GPRS. So GPRS is what our phones use, like this one. This is a GPRS only, but this one is GPS and GPRS. So once you get your GPS coordinates from the satellites, you can then send these GPS coordinates to the server, to your server, using the same module. And your controller is here. So this one has two controllers for different purposes, but so this is the controller that talks to the GSM. So this controller here will talk to the GSM and ensure that it can get the GPS coordinates and send them to the server. And then on the server, it can send maybe after every second, after every 5 seconds, depending on how you configure it. On the server, once you open, you can now embed your code, or rather you can use what you call Google Map APIs, and you're able to actually see, because the GPS coordinates are being updated every second or after every 5 seconds, depending on how you program it, you can actually see where that vehicle is. This is how we are able to track matatus in Kenya. So using IoT. So Florence has asked if the code can be in any language. Actually, I would say, let me answer a yes to that. The code can be in any language, but it's dependent on what controller you are using. So most microcontrollers, or rather embedded systems, would prefer using C or C++ language. Reason being, C and C++, they are languages that are compiled. And once you compile the language, it gives you a compiled file, which is a binary file. We call it the binary file. So binary is a machine language file. It's in machine language, ones and zeros. So these ones and zeros are what are written into what are uploaded into the microcontroller, because microcontroller does not have much. But then, if you are writing your code, for example, using Python, so yeah, I'll answer the other question. So if you are writing, for example, using Python or a high-level programming language, what will happen is most of these microcontrollers cannot handle that. So there are programs, I believe I've seen one, that can change a Python code to hexadecimal. I haven't interacted with it, or Python code to binary. I haven't interacted with them, but if you write it in Python, there are other controllers that you can use. We call them this system on modules. So system on modules or system on chips, they are processors which are bigger than what you have here, and they can run high-level languages. But then with that, the cost factor becomes a problem because you need a bigger microcontroller and a bigger memory. Because those high-level languages, they need a translator. For example, if you're writing Python, you need a Python program to be able to translate that code. If you're writing Java, you need Java as well installed. So basically, the best would be to write it in a low-level language, C or C++. But then if you're good in Python or Java, it's also okay. You can use boards like Raspberry Pi, Udo board. We have several of these controllers that can actually support those languages. So thank you for that, Florence. So there's another question. For the speed governor processor, how do you program that? So, so there are several ways of programming this processor. And this particular board here that I have in hand is mass produced. We have tens of thousands of these boards right now in Matatus. So what we do is we do not program these boards one by one. We have what we call mass programming machines when doing mass production. And these mass programming machines, you just take the processors. So these ones are done in China. So the processor, so we give them the design, everything, and then they program the processors for us. So they go through a machine, and then the code is already loaded, and then it's just embedded into the microcontroller. But then when it comes here, and for example, it has a challenge and we need to reprogram the microcontroller, we have these pins here. So these pins are used to reprogram the microcontroller if there is anything that we want to add. So basically, we connect. So we use our computer. We write our program. So we have what we call IDE. IDE is Integrated Development Environment. So we have IDE that we write our program using C++, and then we compile using our computers. And then after we compile, we have what you call a programmer. Sorry, I did not carry a programmer with me, but a programmer is a module that has a USB connection, and then on the other side it has pins that are actually headers that can go into these pins. So we just connect a programmer and the headers. And on the software that we use, which is the IDE, you just select that you want to program the board, and you just click program, and automatically your program is uploaded to the board. So basically that's how it's programmed. So another question, do you use Arduino IDE? Sometimes we do use Arduino IDE. Arduino is very good. So we have different types of Arduinos. So there's a big one, mega, small one. So Arduino IDE is good. Arduino is mostly based on the Atmel microcontroller. So the microcontroller here is Atmel. So if I'm using an Atmel microcontroller, maybe on the board, for example, the speed governor, I can use Arduino IDE, and I can actually program my my speed governor using Arduino IDE. But then it's limited to the microcontrollers that I can use. For example, if you look at this microcontroller, this one is a more powerful microcontroller from a company called STM, and this STM is it's a what you call a 32-bit microcontroller. I know we don't have much time, but once I'll give my contacts, because I will on the training I can explain further on how to differentiate the two. This is an 8-bit microcontroller. This is a 32-bit. And for this particular one, we don't use Arduino IDE. We have IDEs that are better for this particular microcontroller, which is a 32-bit one. And we also have other microcontrollers from other companies, Texas Instruments and so on. And these microcontrollers, if you have to program them, they have their own IDEs. So yes, you can use Arduino IDE. You can make products based on your Arduino and actually put them into the market, because we actually have a speed governor and also a GPS tracker in the market that is purely based on Arduino. And we've actually sold thousands of those in Kenya and Nigeria as well. So thank you for that. And then there's another question I'll just go through. So FTDI programmer, or yes, you can use FTDI programmer. Those who understand FTDI, so meaning that it's just a serial communication device from your computer to your microcontroller. It can also be used to program, especially Arduino. And also there's Godwin, who has said he wants to get started on Internet of Things. Yes, I will give my contacts after this, so that those who are interested in training, they can actually come for the training. So any roadmap, yes, I'll give that, Godwin. And then, assuming that you want to automate tasks and devices in a standard size home, is a Raspberry Pi sufficient? Yes, you'll also need, so let me ask this question in such a way that everyone will understand. So Brian is trying to ask, so you are at your home and you want to automate tasks in your home and also devices. Is a Raspberry Pi sufficient? I have a Raspberry Pi here. Unfortunately, I don't have a Raspberry Pi. A Raspberry Pi is a board like this, which is, a bit more powerful than this. So in a Raspberry Pi, the difference between this and a Raspberry Pi is that for this one, you do not have like an operating system. For a Raspberry Pi, you need to install an operating system. And it makes it more powerful than the Arduino. So if you want to automate your home, is a Raspberry Pi sufficient? Yes, it is sufficient. But you also realize that you need other peripherals. You need sensors, you need actuators. I once did an automation, a hotel automation, using Raspberry Pi actually. That was Best Western Hotel, Best Western Plus. It's near Jibanji. And in some of their rooms, they wanted, just luxury. They wanted comfort. And, you just walk into the room, they give you a tablet, you can open the curtains, you can close the curtains, you can, just do things with the tablet. You can even switch on the lights. You can even change the color of the light. If you want yellow light, if you want red, if you want brown, you can do all that using the Raspberry Pi. No, using the tablet. But then how was the Raspberry Pi communicating? So the Raspberry Pi was the center, like it was centralized. So the tablet was connected to Wi-Fi. The Raspberry Pi was connected to the same Wi-Fi. So if you open that application and maybe select curtains open, what will happen is a signal will be sent to the Raspberry Pi using Wi-Fi because they are connected to the same Wi-Fi. So the Raspberry Pi will receive this command, open the curtain. So what will the Raspberry Pi do? So I connected what we call a radio frequency network, which is interconnected. It uses, it's called a Zigbee. So this Zigbee network, I was able to, use the Raspberry Pi to send a signal to a module, a radio frequency module that was connected to a motor on one side of the curtains, and instruct that module, hey, open the curtains right now. And then the module will in turn send a signal to the motor, and the motor will start rotating. And it will rotate until the curtain is fully open, and it will stop. And it will also send a feedback signal to the Raspberry Pi that the curtain is open right now. And then the Raspberry Pi will in turn send a feedback to the tablet that the curtain is open. Then you can actually see their curtain open. So basically, that is how you can use a Raspberry Pi. You can even use that to control your TV. You can use that to control anything that you want in the house. So basically, yes, Raspberry Pi is sufficient. And then someone has asked, what's the mode of communication between the speed governor and the server? Is it through the GSM module? Yes, it is. So if you can see the speed governor here. So this is, I don't know if it's very clear. It's called SIM868. So if you just go to your browser and type SIM868, it will give you the datasheet for this. So just type SIM868. So this one has, as I explained, it has GPS and GPRS. GPRS is, 2G. So what happens is, to communicate to the server, you will get the GPS coordinates, and then using GPRS, we have the microcontroller, just like as I explained, the Arduino and the GSM module. So the microcontroller will send commands to the GSM module, connect to the server. It's like how you browse, when you go to your phone and browse. Basically, you're connecting to that server. If you browse maybe Google, you're connected to the server and getting information from there. So basically, that's exactly what we are doing. We're just telling them the module browse, and as you browse, send this information to that server. And then you will the server configuration. Right now, I don't have much time to go into detail about server configuration, but yes, you need to do some server configuration, and then this one will send information to the server, and then that's how you get that information. So is it possible to integrate both the fingerprint sensor, RFID module, and on an Arduino microcontroller? Then comparing Arduino and Raspberry Pi, which one would be the best option to consider in this case? So I'll first answer the first question, which is can you integrate fingerprint and RFID module? Yes, you can integrate fingerprint, this, one controller. Have fingerprint sensor, it can have RFID sensor, it can have flow meter. This is a flow meter, flow sensor, can have GSM, it can have motion sensor on one microcontroller. You can have so many of these sensors on one microcontroller. That's the beauty of these controllers. You can have as many sensors as you want. And then you can also have what we call actuators, the drivers, whatever is being actuated. So after the sensor gives you the information, what do you do with it? Do you switch on a motor to open the curtain? Do you switch on a bulb? Do you sound an alarm? Do the actuator? So what is being driven after you get your signal from the sensor? So now the beauty of this is you can integrate as many sensors and actuators as possible. And then the other thing about comparing Arduino and Raspberry Pi, which one would be the best option to consider in this case? So, okay, it's actually, most people have been asking this question. Between Arduino and Raspberry Pi, which one is better? Which one is better? I think all these microcontrollers or computer systems, they have their advantages. For example, Arduino, this is a microcontroller. This is not a fully fledged, it's actually a computer, yes, but it has very minimal resources as a computer. But now for a Raspberry Pi is a full computer. That's a computer. So it's more powerful than Arduino. But does it mean a Raspberry Pi is better than Arduino? No. The question is no. It depends on what you're using it for. So Arduino, when you switch it on, it does not have an operating system. Without an operating system, it does what we call real-time operations very well because, there's no booting time. It's very hard for it to hang, like freeze, no applications. It's just the code, bare minimum. So you switch it on and it runs. It can run for years, 25 years, 30 years without any problem because it just runs on the code itself, not on operating system. It's just a loop. Basically, that's it. But then a Raspberry Pi, it has advantages. You can put for example, you want to create your own CCTV at home. You want to have your camera and, you want to be able to stream and see it on the phone. Your own CCTV. You cannot use Arduino for that because image processing, Arduino cannot do that. It's very limited. It's just an 8-bit microcontroller. It cannot process any image, or rather, image processing will take a very long time. So what do? You use Raspberry Pi for that because Raspberry Pi is very good for image processing. It can, do very heavy stuff because it's more powerful. It can do heavy stuff. So basically, you can't compare the two on the same platform. Both have their advantages and they have their limitations too. So, like for this particular case, just looking at that particular case where you are asking about fingerprint sensor RFID module, that's pretty simple. An Arduino can actually is the best for that. You don't have to use a Raspberry Pi. And also something else. I'm not saying don't entirely use a Raspberry Pi. A Raspberry Pi can be used for that. It's just that you're killing a mosquito with a hammer. You can use a Raspberry Pi, and if maybe you're not good in C or C++, you're good in Python and Java. I wouldn't advise you to also use a Raspberry Pi because you don't have to change your language. So basically, those are the factors to consider. So someone else asked, if you integrate many sensors and actuator, would the microcontroller have? Actually, it depends on your code. It's not about the sensors and the actuators that you integrate. It's your code, the efficiency of your code. Because microcontrollers, they just do exactly what you tell them to do. These things are, the memory is not that big. It's very limited. And then sensors and actuators, these are just signals. It's just a signal, whether it's 5 volts or 0 or, it's just voltage signals that you are inputting or outputting from this. So the code matters. And secondly, your circuit as well, your electronic circuit matters because if you have so many actuators meaning you are driving voltage to many of these modules, there is a maximum amount of current that you can output from the microcontroller. And if it exceeds, then it means that the microcontroller cannot actually drive your circuit. So basically, it's in terms of numbers, it has up to 53 pins, this one. So it means you can connect up to 53 different control, like sensors and actuators. Actually, it's more than 53 because the pins are, there are 53 digital pins, and you have some analog pins, which are about 16. So you can actually connect more sensors and actuators. And then your program, how you code, will depend, how the microcontroller will function. But it will not hang. So maybe you can highlight the processes or steps from a prototype to developing an MVP. So yeah, thanks for that. So this, as I showed, is a product which is out there in the market. And for you to come up with this product, this is the speed governor. Maybe for those who have joined, this is the speed governor, which is now in the market. Everywhere, most matatus, they're using this speed governor. And for us to develop this speed governor, we did not just sit down and start developing it. No, we have processes. So the first process is what we call proof of concept. So proof of concept, you take an Arduino, you take your GSM module, you take other sensors. For example, when you want to control the speed of a vehicle, there are several ways to control the speed of a vehicle. One of the ways that we normally use is using a relay. And this relay is connected to the, so depending on which vehicle, mostly you can connect to whatever controls the throttle of the vehicle. So if it's the ECU, you can connect it to whatever controls the ECU. If it's the throttle itself, maybe for all the vehicles, we connect it straight to the throttle. We can connect it to the fuel injector. We can connect it to the, whatever, but it's just a signal. And then once we determine, we determine what kind of vehicle, we are able to connect the vehicle signals here. So we connect, and then We have our controller and our GSM. And then we get a signal from the vehicle, what we call the speed signal. So on the speedometer of the vehicle, we have so many cables. We have to identify which one is the speed signal vehicle. So we have to raise the vehicle using some jerks, and then we identify, this is the speed signal. Then we take that signal, put it into one of these pins. We just tap from it. We don't cut it. We just tap a wire, and then we put it into one of the digital pins. So that signal is a frequency-based signal. So basically, it switches on and off. It's a sensor, that maybe after every rotation, it can send a pulse and so on. So depending on the type of vehicle, the pulses that we get are different. For example, for Toyota, it was about 53 to 54 pulses at 80 kilometers per hour. And then for Nissan, it was around 110 pulses at 80 kilometers per hour. There was another, and I think it was Volvo. Volvo was around 3,000 pulses. So depending on the vehicle that we are dealing with, the pulses are different, but they are all the same. So it's just pulses. So we connect that, and then we have to make sure that our code works. So this is just the simple speed governor. So with these three, you can make a simple speed governor, and then you install that in your vehicle. So once it works, there are other things that we have to look at. For example, we have to follow standards. We have standards for CAPES. We have standards for NTSA. So we have to look at the standards, and then once we identify that we can actually get the speed of the vehicle, we can, limit the speed. We can then store the speed. We have a storage module. Unfortunately, I did not carry it. It has a storage chip, so we can store the data of the speed into that chip, and we can also send the speed information to the server. So once we get the speed from the speed signal, we can send that to the server using the GSM module. So once we identify all that, there are standards for the NTSA, and these standards require several things. You can see, like, it's actually the same thing. Like, we have a relay here, the GSM module here, and the microcontroller here. It's basically a similar device to what I have shown you, the proof of concept. But then what we add is there are several things that now come into play after we do what we call the proof of concept. So during this phase of proof of concept, we not only consider the technical aspect of this, because that is what most students do, but that's where they also fail, because this thing will work very well. Most technical guys, the reason we do technical courses is because we are able to do these things. But then we fail to consider what we call the end user. So we always employ something we call human-centered design. When it comes to production, or rather design of these IoT systems, you are not the user. You are just the engineer who will make these things. But the end user is the one that will benefit from what you have made. So if you make something that is very hard for the end user to use, it doesn't matter what technology you have put in there. The end users don't care about that technology. I'll give you an example, just a very simple example. Go with two machines to some users who don't understand technology. Two laptops. One, a very pretty laptop, colored one. Let it be even or i3 first generation, very pretty one. And then the second laptop, Core i9 10th generation, a very good processor, very good graphics card and everything. But then it just looks, not good looking. For an engineer, or for a technical person, they will go for that one because of the specs. But for any other person, they will go for the other one because of the looks. Unfortunately, most people are not very technical and they will go for things that look pretty and easy to use. So when you are designing your product, it has to be very easy to use and also pretty. So if you look at Arduino and what I have shown you, it has so many pins. You have to connect cables. When you look at the circuit at the end of the day, it looks, it has so many cables. But when you have a device like this, so this is now when you have already moved from the proof of concept and you are now designing for production. So design for production have actually most of the thinking goes to the human-centered design. For example, to install this thing, the mechanic or whoever is installing will have a harness. They will just plug the harness in. So it has a plug and play. So it just plugs into this section. They put the antennas, plug the harness, and then we have a manual. The red cable goes to the battery, black one negative, this to the speed signal, and so on. So it becomes very easy even for the mechanic to do that installation. Because at the end of the day, when it comes to mass production of your devices, mass production is a different ballgame. I will tell you for a fact, I have made speed governors. I have never ever installed a speed governor in a matatu. And if you tell me today to go and install, I will struggle. It's not that I don't know how to install. It's because I made it in such a way that the guys who know how to install, it's easy for them to install. And I did the research. So basically, when you are moving from proof of concept where you just have your simple device, you do your proof of concept, you make sure everything works. Now it's not about the technical capacity anymore. You have proven that you can actually do it. It's about the human-centered design to be able to put your product out there. And the reason why Omata Speed Governor became the best-selling speed governor in Kenya was because of that. We had to look at the human aspect. It's not that it was, any better than any other speed governor, but it's because any mechanic would be like, this speed governor, we install ni rahisi sana. It's very easy to install this speed governor. I would rather install this speed governor than the other speed governor because the other one, I have to do a lot of configuration. This one is just plug, 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 and done. So within a day, I can install maybe 30 speed governors. But for this other one, I can install maybe 5. So I would rather make more profit installing the 30 speed governors. And that is how, when you go to mass production, these are the factors that you should think about. How long does it take to install? How long does it take? There's so many things that you have to think about which are not technical. And that is what informs such a design. So this design, as you see here, there's so much thinking that has gone into it. And that's why it takes some time for you to develop a product that is market ready. But then doing a prototype, like, just doing this, we actually just last week, I have interns here. Last week, they developed a speed governor, a smart speed governor, using, these devices. And we installed it in one of the vehicles. And it's actually a smart one. You can set the, it detects where you are, the speed limit of that location, and it limits the speed for you. So interns have done that here. So basically, doing a POC, proof of concept, is easy. But then going to this, you need to put more thinking into the human-centered design aspect. So basically, the roadmap to reaching here would be, first of all, start with a proof of concept. On the proof of concept, what you are doing, you are just looking at the functionality. Is it feasible? Before you even go further, is this thing feasible? Does it have market? Is it acceptable in the market? Once you have answered your questions and you are able to ascertain that, oh, that thing can actually go to the market and it's feasible, it can be done, then go for it. And you don't have to make very complex stuff. Most guys think of, oh, I can make a drone that, does whatever and whatever. It's good. It's good to think about that. But at the same time, we have what we call red tapes. For example, if you think of something that is out of this world, what happens is there are so many regulations around that. So just think of something which is very simple, and I'll give you another example apart from the speed governor, because speed governor is, it's a good thing. It's a bit more complex. So there's this automation I did at Radisson Hotel here in Nairobi. So they had a problem with the energy, and they had a very huge bill to Kenya Power. So what happened is they contacted one of my partners and asked them, is there a way that we can reduce our energy bill? So I went there, I looked at it, and I was like, yeah, sure, there's a way. And then what was the way? The way was, okay, you guys, you are allowing your guests to switch on the HVAC machines, that is the air conditioning systems, in their rooms, and their windows are fully open. That does not make sense. So why don't we put some sensors into the windows? If they open the windows, the AC machine switches off. A very simple system. Very simple system. Just a sensor, switches, and they were able to solve that problem. So basically, you don't have to think of a very complex solution. You don't have to think of something out of this world. It's just, how do you also improve on things that exist? I remember when I was training some students, one of the students came up with an idea, which was like, things that annoy people. Sometimes, maybe you're driving and then you park somewhere, and as you're walking, you try to remember, did I lock my car? I left it open. So you wonder, like, should I go back and check? And in most cases, most people do go back. You just, you've walked for a long distance, but you decide, let me just go and check. And then you confirm that you actually locked it. Sometimes you realize you did not lock it. So how do you come up with a solution to that? Create a system, a very simple system. Use GSM, use relay, use microcontroller. Wherever you are, send an SMS to this guy. This guy will receive the SMS and tell the relay to lock the vehicle. Simple. So you actually solved that problem. Package it into a very nice product. package it very nicely, something like this. Just package it and then it has cables like this, and then people will just buy it from you. You sell that. It's a product in the market and people will need it, definitely. So that's how you make products. And, another system is like there was this system about, sometimes you go to the supermarkets and when you're in the supermarket, you want to take rice, alafu unaenda the other side, you want to take, I don't know, omo. Then ukiuliza mtu wa omo huko, maybe let's say majani, where is majani? They tell you it's on the other side where you left the rice. Then you go there, and then you ask someone else, say something else, and then you keep going different places in the supermarket. What if we had a system that actually shows you where everything is? What if we had a trolley that had, you just select what you want and you go there? So some of the things that we see, we see problems, we see opportunities, but we don't think these are opportunities. We think they are problems, but problems give rise to opportunities. So some people are like, supermarket in a bow, supermarket in a bow. It's boring. It's an opportunity for you to create a system for them. So that's how we come up with IoT solutions, because we have to see this problem. It's an opportunity, do some digging into it, get to understand, and we make a product. So basically, that's what we do here at Feather Electrics. So Florence has asked, will there be another webinar? I'm interested in knowing. So I will actually be doing training on, I've been doing training, but most have been physical training. So I will be starting also some online training on embedded systems at IoT. So I think I will just share my email so that if you are interested in the training, you can actually just reach out on that email. So okay. So I have just shared my email on the chat. So share the other email. So you can reach out if you are interested in the training. And just to encourage you, I have been mentoring a lot of guys in terms of system development, IoT development, and how to think of solutions, because most of us look at problems and you think, oh, these are just problems. But how do you get an opportunity from that? Because even for me, I used to work at IBM. I was an engineer, hardware engineer at IBM before I decided to be an entrepreneur. IBM is a very good company. It's one of the best companies in the world. And, they pay very good. They have a very good team as well. And, opportunities to learn and all that. But what I saw is that, in this field of IoT and embedded systems, there are so many opportunities here. You just walk, and as you're walking, something happens to you and you're like, I want to create a solution for this. And I'll tell you, you see like that one for cars, like forgetting if you lock your car, that is me. I forget a lot. I have friends who forget a lot. And I was like, I'm going to make money out of you guys. You're my friends, but you pay me to give you this solution. And that is how you actually make a business out of IoT. Um, so basically, this is what we have been doing for the last several years. We've been partnering with companies as well uh, and marketing most of these products. And product development, as it starts, it's very easy. And once you put your first product out there in the market, it feels awesome. So I would like to encourage all of you just to, not overthink about, um, systems, complex systems. I don't know all that. Think of very simple solutions. You see, like the way I've just told you, my funny problems. Forgetting things. Sometimes someone wants to switch on something at home. They just want to switch on the lights. Simple. A very simple system that can do that automation. People just want to monitor something. Maybe if there's water, they just want to see on their phone. And people are willing to pay for that. So the thing is, find a problem that is a pain to many people. Of course, a pain to you and also a pain to many people. Just confirming with your friends. And then, create a solution around it. And that is how you make your IoT product. So, so I have Keith Bryan, wants to be mentored. I'm open to that. You can drop me an email, and then you can talk from there. So thanks, guys, and I would like now to open this session for any comments or suggestions or questions. You can unmute yourselves. Thank you for that.
Oh, hello, Nick.
Hello, Alex. Who is this?
Oh, Keith.
Keith. Yes, Keith.
Okay, so my question is the security of IoT, like creating secure devices which can't be tapped or hacked by hackers.
Okay.
Yeah, since the devices are connected to the Wi-Fi, one can easily trace you and up to your phone.
Okay, so initially when IoT started, yes, there was an issue of security, and security was a big concern because IoT devices, they were not secure and all that. But as of now, security in IoT has been implemented, and so depending on what protocol you use, the systems are now more secure, especially the networks. They are more secure than before. So basically, security is another layer which is on top. So if you look, for example, at these modules, the initial modules maybe could do HTTP protocols, but these ones, they can do HTTPS. If you look at microcontrollers, this microcontroller is a basic 8-bit microcontroller. If you look at this microcontroller, it's a 32-bit, and it has encryption. So basically, right now, the security of IoT devices has gone very, very high. And you don't have to worry about security, because even those who can hack into your data, the people who are more intelligent than you. So yeah, that's it. So Alex?
Thanks, Nicholas, for such a good presentation, and thank you, Chris, for setting it up. I just wanted to share that IEEE will be running an annual Africa IoT Challenge. So if people have ideas that they would like to participate in that competition, they should be on the lookout, and they can continue learning, getting mentored, and try their hand in that. Last year, we had a Kenyan team that reached number 2. So hopefully we will keep on having Kenya teams doing quite well. So I just wanted to share that IEEE is running an Africa IoT Challenge, which now is on an annual basis. So be on the lookout for that. Thank you.
Many thanks, Alex, for sharing that.
Hello, Nick.
Yes, hello.
Yeah, so this is Chris. Thank you for that presentation. So yesterday I came up with this article that was talking about ethics in terms of big data. And when we say IoT, we start talking about data. We are sending data from our devices to server somewhere, and maybe these devices are communicating. But now the law is quite back in terms of technology. So I was asking, which ethics do we need to practice as IoT developers to ensure that our the users of our devices feel safe? There is no discrimination in terms of who would use our devices, and biasness in terms of developing these devices. Thank you.
Okay, thanks for that question, Chris. So in most cases, you know, we have, when you want to be competitive, especially in this industry, you know, ethics is one thing which is actually very, very important. And ethics comes to data protection. And, excuse, so when you talk about data protection, we have laws that govern that. You know, initially, people used to abuse IoT and, you know, all these things because we didn't have laws that govern data. You know, data is the new gold right now. And everyone is not looking at anything else. They're looking at data. You know, all companies, all big companies, Facebook, they're looking for your data. You know, Google, they're looking for your data. Microsoft, everyone is looking for data. And the way you use that data is now very questionable, of course. You know, Facebook has had so many cases, you know, how do you use the data? But then you have to be ethical when you come to these IoT systems. You have to follow laws. You know, you have to commit yourself to some of these things. And I'll tell you a very good example. So just the other day, I was creating a telematics systems for matatus. And, you know, telematics involves also capturing passengers, you know, getting driver information, getting, you know, a lot of these things. So we had to like ensure that we commit ourselves to a certain ethical standard. We have to commit ourselves to some laws so that when we go to maybe the certificate, what is it called, the communication authority, we must declare how we are going to use this data. Because at the end of the day, if you use data in a way that, you know, it's not permitted, then you will actually end up in jail. So, and this is not, you know, for these IoT devices, sensor data, this data, these are simple things. You know, you can use the data that you want. You know, if it's agricultural, if it's temperature, whatever, these are simple things. But the data that you have to be sensitive about is personal data, you know, personal information. If you are getting someone's personal information, for example, their images, their videos, you have to be very cautious about that. But otherwise, you have to follow some ethics when you are dealing with the data. Yeah, thanks for that. Thanks for that, asking that, Chris. So, any other question? So thanks, Godwin. Please reach out. I'll be available, and we can always connect. And I'm very grateful to everyone for attending this session. I will be communicating to those of you who are interested in going deeper. That is in embedded systems, IoT, product development. You can reach out to me, and then I will definitely reach out to you, and we can plan on how to proceed with this. I also thank you, Chris, for organizing this, and Alex as well. I'm grateful for this. So thank you so much. So back to you, Chris.
Okay, thank you, Nicholas, for that great session. I just love the way you took us through presentation. In presentation, people tend to focus on the PowerPoint. This was very engaging, good stuff on what you were explaining. Thank you for that, and thank you for sparing your time to share with us. So maybe before I end the session, I'd like to give Alex a minute maybe to say something before we come to the conclusion.
Okay, thank you, Chris. Mine is just to again give a vote of thanks. So thank you, Nicholas, for making time. We called you and you came at a short notice. So we'd like to thank you for that. Chris, again, also, we are quite grateful that you took your time to organize this, and then the attendees, the participants. We also thank you for being part of this webinar. We will try to organize many more webinars regarding IoT and other related subjects. So just be on the lookout, and I hope you'll be attending. Thank you. Back to you, Chris.
Thank you very much. So I also want to thank you, the participant who joined us this evening. I hope the session was also informative for you too. Maybe I got an email from Nicholas. For those of us who are interested in maybe digging deep, for me personally, IoT and AI is quite an interesting topic to get into. So we just reach to you, Nick, for a way forward. But unless anyone else has any other question, something you'd like to point out, from my side, I would like to wish you guys a good evening or day ahead. And thank you for joining this webinar. This was hosted by IoT Training Computer Society. Alex is our chair, and we look forward to great sessions with you all in the future. Thank you very much. Yeah, so if there is no one with any other business, we can just call it a day. Live at our own pleasure.
Thank you so much. Looking forward to talk to you guys.
Thank
Bye-bye.
you. Bye.